Variance of the sum of two variables. In this section, we will discuss how to calculate the variance of the sum of two variables. As you will see in later sections, there are many occasions where this is important, considering the following situation. You have two populations. You sample one number from each population, and then you add the two numbers together. You do this over and over again until you have a great many sums. The question is, what is the variance of the sums? For example, suppose the two populations are the populations of 8-year-old males and 8-year-old females in Houston, Texas, and that the variable of interest is memory span. You repeat the following steps thousands of times. First, sample one male and one female. 2. Measure the memory span of each. And 3. Add the memory spans. After you have done this thousands of times, you compute the variance of the sum. It turns out that the variance of the sum can be computed according to the formula shown here. The first term is the variance of the sum, the second term is the variance of the males, and the third term is the variance of the females. Therefore, if the variance on the memory span test for the males and females respectively were 0.9 and 0.8, then the variance of the sum would be 1.7. The formula for the variance of the difference between two variables, memory span, in this example is shown here. Notice that expression for the difference is the same as the formula for the sum. Intuitively, you might think that the variance of the difference would be smaller, but that is not the case. More generally, the variance sum law can be written as shown here. This is read as the variance of x plus or minus y is equal to the variance of x plus the variance of y. However, these formulas for the sum and differences of variables only apply when the variables are independent. In the memory span example, we have thousands of randomly paired scores. Since the scores are paired randomly, there is no relationship between memory span of one member of their pair and the memory span of the other. Therefore, the two scores are independent. Contrast this situation with one in which thousands of people are sampled and two measures, such as verbal and quantitative SAT, are taken from each. In this case, there would be a relationship between the two variables since higher scores of the verbal SAT are associated with higher scores on the quantitative SAT. Thus, the two variables are not independent, and the variance of the total SAT score would not be the sum of the variance of the verbal SAT and the quantitative SAT. The general form of the variance sum law that takes non-independence into account is presented in a section in the chapter on correlation.